A little bit of a review here. So learning target 1, it was the very first thing that we learned, and it was about products. And we learned that if you took an a to the x and multiplied it times an a to the y, that your answer was keep the base and add the exponents, right? So that's what we learned first. And then we did a little bit with that. It got a little more involved than that, but that's what it started out as. And we multiplied, that's P, our coefficient. And then we added our exponents. Okay? Those were the general rules that we followed when we did the products with exponents, or powers they call it instead of exponents. Okay? So what that looked like was, let's say, a to the third times a to the fourth. It looked like 3a's times 4a's, which was 7. And the reason I write it out like this is to kind of show you that if you get confused, and because now, since we've learned this, we've also learned that we multiply exponents too, right? And so some people now kind of think, oh, it says multiply, so I'm going to make that x or a to the 12th. Well, I don't see 12a's. I only see 7, right? So sometimes kind of going back to breaking it all down to no exponents really can help you. So if you're confused, do I add them or multiply them here? Break it down. And do you see 7 or 12? I see 7, okay? Then we added in a coefficient. All right? And that's where rule number 1 comes in. We multiplied those coefficients, so that's where the product part of it comes into play. And that gives you a negative 35. And then 10 plus 1 is going to give you your 11. Okay, and there wasn't really much else to it than that. So everybody okay with rule number 1? Or exponent rule number 1? Okay, learning target. So then we moved over to, and I'm going to switch to red. You can follow me if you want, or I don't know if the markers are too fat to write with, if that's annoying. But so the quotient of powers property was learning target number 2. And that property said that if I take a to the x and divide it by a to the y, that I'm going to get a to the x minus y, right? So what that looks like here is for number 1, we divide the coefficients. And this time we subtract the exponents. Let's do. So what that looks like is, let's say p to the 11th over p to the 3rd. You know, we could write it out wrong ways. I'm not going to write 11 p's and 3 p's, and then you picture what you know what I'm talking about. So cancel them all out, and that leaves you with p to the 8th, right? However, if I flip it upside down, and the problem that we were originally given was that, then your answer was a little different. It wasn't p to the 8th. This time, when 3 of these canceled out 3 of these, nothing is left in the numerator, and your answer was that. So that kind of is, so the division has a few more tricks to know than the multiplication part did, right? So this is what it looks like when a coefficient comes into play. Negative 50x to the 12th divided by 5x. We divide our coefficients, which is negative 10, and subtract our exponents, and 12 minus 1 is 11. If this was flipped, though, and just the 5 and the 50, I guess I could have kept it there. If the 5 and the 50 were flipped, but the x to the 12th and the x stayed put, how would that change what I did with my coefficients? So I kind of want to go up and add something up here. So instead of dividing, can I reduce also? So let's say you can reduce or divide. Because sometimes they don't divide evenly. You're just reducing it. So let's go ahead and reduce 5/50ths and get 1/10. And that's kind of where somebody said to me earlier in the week, how do I know where to put the 10? How do I know if the 10 goes in the numerator or in the denominator? That's how you know. Are you dividing and getting a whole number, or are you reducing? Okay? And then this is still going to stay up there. And the 1 isn't necessary because the x to the 11th is there. You have to have something there. Okay? Yeah. Nope, thank you. And then one more unique thing can happen in division. The variables sometimes can cancel. And that would be like if I have 14x to the 5th divided by 2x to the 5th. So 14x to the 5th divided by 2x to the 5th. Those completely cancel. I don't need an x anywhere in my answer. My answer is just 7, right? So a little bit more going on with division. Okay, so let's remember both of those. And those are the two we learned before Easter break, right? Okay, now ideally, your first check for understanding, it was only these two. It would have been 1, 2, and 3. And then your check for understanding would be all combined. But we didn't have time for that. So let's move on to, I'm going to move on to green. Learning target number 3 was the power of another power. And that said, if I take a to the x to the y, that's going to give me a to the, not x plus y, not x minus y, just xy. There's not really one easy word to write here. So this is where we raise the coefficient to the power, meaning the power of whatever exponent's on the outside, right? Okay, and Esteban, this is where you were absent for, so this is going to be kind of a good little way to give you a preview into it. And then we multiply the exponents, right? All right. So go ahead and get that written, and then let's look at what that looks like. That looks like me taking an x to the 4th and a y to the 5th and cubing it. And that means basically 3 of these. It means x to the 4th, y to the 5th, times x to the 4th, y to the 5th. I do not expect you to write this all out. This is just kind of showing you, like up here, that now that you kind of got rid of that exponent, now it goes back to this, right? It would be add 4 plus 4 plus 4. But you're not going to really do that because you're just going to multiply the 3 times the 4. So this is going to be x to the 12th, y to the 15th. This is showing you why you multiply. Because you have 3 groups of 4 and 3 groups of 5 to get 15. That's why it's multiplied, okay? Then when our coefficient comes in, like say 2a to the 1st, let's say 10th, I want to do that, b to the 2nd, c, and let's cube that. So I'm going to cube 2, not multiply it by 3. I'm going to cube it. That's what number 1 says, raise coefficient to a power. Whatever power's there, raise that coefficient to that. And that's the same as 2 times 2 times 2, which is not 6, it's 8. And then you know the rest just kind of, that's a 30. And then b to the 2 times 3 is 6. And I want you to know, it's kind of confusing when there's nothing there, but 1 times 3 is 3. And then we need to remember what to do with the whole even-odd thing. So if I have negative 4a to the second power versus negative 4a to the third power, when your coefficient is negative, you're going to have a different answer than you would if a different sign than if it was even or odd. Here, each 4 has a partner. Negative 4 times negative 4 is positive 16. But take that positive 16 and multiply it by another negative 4, and you're going to get a negative 64. Okay? This should not be a teaching. That's kind of why I'm flying through this. This is a review, right? This is a reteaching, not a relearning thing. So the last thing I'm going to write in this here is that a negative to an even power is positive, but a negative to an odd power is negative. And that's all I need you to know for that. Dylan, did you have a question?
Yeah, but never mind.
Okay. All right. Okay, I'm on my last color here. We're going to fill this bottom section in. Then we're going to watch a little music video. Okay. The thing I need you to keep in mind about when I take all 3 of these and combine them is this. That you may be asked to take a fraction and raise it to a power. And when you take a fraction and raise it to a power, all you need to know is that you take each, the numerator and the denominator, separately to that power. So this would be a to the x power divided by b to the x power. Now we learned that you might need to do some reducing or cleaning up inside first. So if I ask you to redo or take 5/10 to the second power, I would get 25 100ths, but then I'd have to turn around and reduce 25 hundredths, right? Could I reduce 5/10 first and get a half, and then square the half and get 1/4? Okay, so I equate it to like cross canceling before you multiply, right? You're just gonna it just makes more sense to kind of get it down first. Okay, so I'm gonna give you the mother of all problems and have it be all 3 of these with positives and negatives and some canceling maybe and this and that, and let's see if you are with me on it. So you're only going to probably have enough room to copy it here. We're going to have to finish it on the back. So I want you to take 2x squared and cube it. Then I want you to multiply that by 3x squared. Then take that product and divide it by 2x to the 5th to the 4th. And then when you get that answer, I want you to square it. It looks insane. You can do this though, okay? Are you ready? Let's do this. So I'm just going to you can go on the back if you want to. I don't know if you need to recopy it or you have it in the front. Okay, so follow me for a second. Take this parenthesis to the third power. Take this parenthesis to the second power. Take those answers and multiply them. Take that product and divide it. Take that quotient and square it. Ooh, did you follow me?
No.
Okay, I'm going to say it again. But I know you can get this. Take this parenthesis to that power. This parenthesis to that power. Picturing it? Then I need to find this product. Then I need to take that product and divide it by this to get a new quotient. And that new answer then gets squared. Let's do it, okay? So let's take 2x to the second and cube it. 2 cubed is 8. This is where you say to yourself, do I multiply them, do I add them, or do I subtract them? Then you picture this thing and you go, oh, so they're on the outside of the parentheses, so this is going to give me 6 of them. I'm going to take that 8x to the 6th and multiply it by whatever this works out to be. And 3x squared is 9x squared. And while I'm at it, I may as well go ahead and do the, where are we at? It's a little light. Okay, gotta get brighter. I may as well do this one too. 2 to the 4th power is the same as like 4 squared. 2 times 2 times 2 times 2. X to the 20th. And then we already learned the hard way, some of you did, that if you forget to put this, you may forget to square your final answer. So drag that along. Okay? So are you with me so far? Can we make our checkpoint here? All right, next step. Multiply and add. So let's do 8 times 9, 72. 6, what with the 2? What do I do? Add, divided by 16x to the 20th. And I still want to square it. But I gotta work this out. And unfortunately, it does not go evenly. So 16 does not go evenly, but it does reduce. 8 is the GCF, right? 4 would work, but 8's better. 4 would just mean you gotta break it down again. So 8 fits in here 9 times, and 8 fits in here twice. And this x to the 8th comes down and cancels out 20 or 8 of these, which leaves me with that. Almost done. I got one more thing to do. And square it. And so that's why this rule is really important to know, because you may stop here and say, I don't know what to do next. Okay? Could you just think of it like this? Isn't that really what that is? Isn't it just 2 of the same things? Well, I don't know why I put a 10 there. Now, isn't that really what it is? So don't you just multiply straight across top, straight across bottom, right? Or you say, I'm just going to square 9, and I'm going to square 2x to the 12th. And that's going to give me 4x to the 24th. Did you follow me? Yes? Dylan?
I just have a question.
Yes.
Are we allowed to put it in proper and put 20?
No, I don't. Wait, say that again?
Like 20 in front and then 1/4 x 24.
20. Where would it put 20 somewhere?
Like on the left, like out of the fraction, like 20, and then instead of 81, it's 1.
Oh, no. I don't want, yeah. Nope. We are always going to, that's a great question, because he's saying 81 over is this, but we're going to, yeah, we're just going to keep it like that. You won't ever see an answer like that. That's thinking, but it's not what we wanted to do. Okay? All right. I have a